Ibrahim, welcome to Computing Education Things.
Thank you very much, Daniel. Thanks for inviting me.
My pleasure. So today we are talking about code reading skills, and I really think we don't talk enough about this topic, and we don't practice reading code much either. So if that's my opinion, what do you think, Ibrahim?
Let me begin by saying that code reading is a fundamental skill that we should be talking a lot about and discussing a lot. Whenever we learn a language, whether it's a human language or a computer language, we usually talk about being able to read in that language and write in that language. And we can argue that reading is a prerequisite for writing, because if you write, you should at least be able to read what you've written, right? It's a fundamental skill that everyone learning programming should be good at. And I can also argue that it's probably even more important these days with generative AI, because the way we've always been programming is that we would think about a solution for the problem and then probably scribble a bit on a paper or so, but then we go and write code and then probably debug it. But now with generative AI tools, the cycle is a bit different, where we more and more generate code and then read that code and decide whether that code does what we want it to do. And then either accept that code and move on to generating more code and reading that code again, or maybe fixing the code, reading it again, deciding whether it's fine or not, and so on. So we could argue that code reading is fundamental, and it's even more important these days to be good at code reading.
Yeah. So I think, Ibrahim, we can learn so much from you today because you recently published a paper with other teammates about code reading skills, right? So I want to start saying that this is not a philosophy podcast, but it's true that when we talk about understanding, we always have to really know what is understanding, right? So today we want to talk not about the written part, but about the read part, and more specifically about novice programmers or intro to CS students. So let's define, right? How do you personally conceptualize what it means for a student to understand code?
That's a good question. We could argue forever on whether someone really understands something or not. But when we are teaching code reading and assessing code reading, we want something practical to use, even though it might not be a bulletproof way of knowing whether the student understands the code or not. But at least if it works 95% of the time, then it's good enough. Right. So what most instructors do is that they would show a piece of code to the student, give them some input, and ask them for the output of that code on that input. And so the assumption is that if the student understands what the code does, then they would be able to give you a correct output for that code on that input. So that's what we call code tracing. It's actually capturing only one aspect of code understanding. Because to be able to answer such tracing questions, all you need to do is to be able to mechanically execute the code on the given input. And by doing that, you're able to know what the output is. But does that necessarily mean that you understand what the code does overall? Maybe not. So let's assume that you have a piece of code that reads a set of numbers and then produces, then prints out the second largest number. Now, if the student is asked to trace that code on, let's say, two numbers, they do not necessarily need to know what the code does overall, because they might look at the code and see a for loop, and inside that for loop probably an if statement that does something that compares between two variables. And since the input is small, they would go and execute that comparison and figure out that the output is 1, not 2. But if you ask them, but what does this code does overall, they might not be able to give you a good answer, right? So that's why sometimes instructors and researchers use another type of question, which they call explain in plain English questions, explain plain English, where the student is asked to explain in plain language what the code does. So the student should look at the code and say, oh, this code prints out the second largest element.
Yeah.
Or this code finds, like reverses the array, or this code sorts the array. So giving a high level description of what the code does. So we can argue that that's a higher level of code reading ability or code reading skill than just being able to mechanically execute code and know what the output is.
Yeah. So you mentioned explaining plain English questions. So these questions, I think, are widely used in the industry, in the academia to assess code comprehension. But I think these questions also face some challenges, right? When it comes to evaluating students' code reading skills. So maybe you can tell us more about these questions. Why are they? In which cases they are good? In which cases they are not? If there are an alternative, maybe.
Yeah, sure. So when you ask a student to explain what a piece of code does, you probably see a wide range of different answers. So some students might focus on one part of the code and just describe that part instead of describing all the code as a whole. So, for example, if it's a piece of code that prints out the last even entered number, they would look at the code and see some check for evenness, and they would say the code checks if a number is even. So they were able to see that small part of the code and describe it, but not the code overall. So that's like that says something about the ability of the student to read the code. Other students might take the code one line, like a line by line, and describe it and say, well, the code defines a variable and then assigns 0 to that variable, and then it repeats n times reading numbers, and for each number it checks if the number. So they would go like line by line describing what the code does. That tells you something else, right? But if they say the code finds the last even number, this tells you also something else, right? So explain plain English questions give you a rich amount of information about the student understanding, but they rely on the ability of the student to communicate what they have in mind.
Yeah,
that's a challenge, and it's a challenge from two dimensions. The first is that we're assuming that the ability to communicate what you have in mind is perfect. And so if the explanation is not good, then the understanding is not good. And that assumption is probably not always correct. And the second challenge is that from the instructor side, where the instructor has to infer from the explanation the understanding of the student. And so that takes time, and sometimes it's subjective.
Yeah. So yeah, we can talk about your paper here, because I think it's interesting, the example of the CS1 students who, I think all of them were Arabic speakers, right?
Yes.
But the material was in English, and the exam had both VIT, right? These questions you designed with trace code, right, on small and large inputs, and these explain in English questions, right? So basically, I guess you found some differences or insights, interesting insights here that you can tell us about this experiment, and tell us about that.
Yeah, sure. So what we tried to do is to design a code reading question that is able to differentiate between students who can trace code but cannot read code. That is, they see the different parts of the code and understand the different parts, but do not see the whole code. So that is, they see the trees, but not the forest. So we want to identify those students compared to students who see the forest and the trees. So they're able to see the purpose of the code. So we wanted to design a question that can do that without the issues and challenges with explain plain English questions. So we want to do that without asking students to explain or use natural language. And what we try to do is to come up with a set of inputs that the student can trace, such that some of these inputs require only tracing, but other inputs the student cannot trace. The student can know the output of the code on those inputs only if they know the general purpose of the code overall. So, for example, if we go back to the example of the code that finds the second largest element, if the student is asked to find the output of that code on a set of numbers made of a random permutation of the numbers from 1 to 1,000, they will not be able to trace that code because they don't know what that random permutation is. And 1 to 1,000 is a large number, so that's not it's a large input, so they don't have enough time in an exam to trace that. But if they know that the code finds the second largest element, then they don't really need to trace it. They can immediately say that the output should be 999. Right. So what we proposed in the paper is to vary the input in a way that allows us to differentiate between students who can only trace and students who can trace and also understand the general purpose of the code. So we call that that question type variable input tracing, VIT. And so variable input tracing is made of small input tracing, SIT, and large input tracing, LIT. And so this type of question is easy to grade. So from the instructor side, they don't have to deal with student explanations and trying to infer from that whether the student understands the code or not. It can be quickly graded because all you have to check is whether the output is correct or not. And it can be automatically graded. So that's a big plus. And from the student side, it's also independent of whether they can communicate well or not. So that's especially good for non-native English speakers, for example, who might have the right idea but express poorly in English. And so in our experiments, what we found was that a good number of students do not express well even in their own language.
So language is not the main problem, right?
Yeah, the funny thing is that so our exams are in English, but some students chose to respond in Arabic anyway. Some students chose to respond in English, and some students responded both in English and in Arabic to the explain plain English questions. And so that gave us some data to analyze. So to compare the English answer compared to the Arabic answer. And in some situations, the Arabic answer was worse than the English answer. So the English explanation was better, although the students spoke Arabic better. And this tells us that it's not always a language issue. Sometimes it's a communication issue. Sometimes it's a laziness issue. Like the student is lazy and is not putting enough effort to make their explanation good enough. So that the variable input tracing question that we're proposing just puts all of these issues aside, because now it's not a communication question. It's just a matter of checking whether the output of the student is correct or not.
Yeah, and I read that you also did some interviews, right? Think aloud interviews to the students. So did you get some insights from them too?
Yeah, sure. Yeah, so we interviewed some CS1 students. We showed them a piece of code and asked them to both solve a variable input tracing question and also to explain in plain English. And what we were looking for was the relationship between the ability of the student to explain the purpose of the code and their ability to answer variable input tracing questions. Because what we were looking for is whether variable input tracing is measuring something similar to what explain in plain English questions are measuring. So that's one thing that we were looking for. And the other thing that we were looking for is the thought process that goes into answering each type of question and how they differ and whether there are different challenges facing students in each one of these questions. So we found a strong association between the ability of the student to answer large inputs, and
Yeah.
and their ability to explain in plain English. So that was one thing. We found a weaker association between their ability to trace small inputs and explain in plain English questions. So that's good for us because it shows that the large input tracing is very similar to explain in plain English, but not similar to small input tracing. So that's one thing. The other thing that we observed was that some students really understood the code overall, but failed to express that well. But we were able to see that because the student gave a poor explanation, but then in the interview, we'd ask them to draw an array and show what they mean by their explanation, and then their drawing would be correct. So they have the correct understanding of what the code does, but their explanation is not good enough.
Wow, that's curious, right? Because they know how to code, how to do the exercise, right? But they don't know how to communicate well. They don't have this clarity for the explanation, right?
Yeah, and we can argue that the ability to explain well is a skill on its own.
Yeah.
For example, you might want to explain what a function does in a doc string or in a in a comment before a function, and you need that skill, right? You need to be able to explain what the code does in a few words. So that's a skill. But the question is whether we want to measure the ability to read code and the ability to explain the purpose of the code both in the same question or not. If that's the purpose, then explain plain English questions are the way to go. But if we want to assess only code reading, then we don't. Then the presence of that communication aspect just distorts our ability to assess code reading skills well.
Yeah. So maybe we can move on to this, how to acquire this ability, right? This code reading ability, because I always thought that, you have to be good at writing the code, or basically code reading skills are acquired as a side effect of writing it, right? Or of writing the code. So I don't know, what's your opinion here? And then maybe we can talk a bit about how CS educators can also, teach good practices in everyday teaching to encourage students to read the code.
That's an excellent question. As you mentioned, we assume that code reading skills come as a side effect of learning code writing. And that's not completely wrong and not completely true. There's a strong interconnection between code reading and code writing. We know that. When you write code, you read code. And so if you learn how to read code, does that mean that you can write code? We don't know. If you know how to write code, can you perfectly read code? Maybe, but maybe not. So one of the issues arises because our ability to assess code writing is also not perfect. So if we ask a student to write code that sorts an array, a student might jot in a for loop and maybe a nested loop because they know that sorting algorithms might need some nested loops, and then some if statement. But if you look at the code does not sort, does something else, or maybe does nothing useful. But as an educator who wants to assess the code writing skills of the student, you might be tempted to give partial credit for that code because probably the student does not have zero knowledge of writing code, so they wrote something useful, and so the student might get something like 70%. Now, does that mean that the student can also read code 70%? So if we're taking code writing as a proxy for knowing how much the student can read code, but our assessment method for code writing is not perfect, then our ability to know whether the student can read code is also not perfect. So the solution for that is basically to try and explicitly target each of these skills separately, instead of trying to target them both together at the same time, right? So when we're assessing code writing, we're assessing code writing alone. And when we're assessing code reading, we're assessing code reading alone. And also when we're teaching code writing and teaching code reading, we do them separately. And so my first practical observation here is that probably CS1 educators might consider dedicating some time, some lecture time, and some assignment time for code reading only, instead of assuming that code reading comes as a side effect when students are working on code writing. And there's a wide spectrum of code reading activities that instructors can use. One of them is tracing. The other one is debugging. Debugging involves a lot of code reading. And then you've got explain in plain English questions. You've got also our newly proposed question, variable input tracing question. You can show students two pieces of code and ask students to tell whether these pieces of code are equivalent or not. This involves code reading, right? And you can give students a piece of code and some output and ask them to figure out what the input that causes that output, right? So there are many different ways in which you can make students work with the code without writing, but just trying to understand what the code does and then answer a question that is based on that understanding.
Yeah, interesting. Thank you. Yeah, it's very interesting the ways you see to try, in lectures and different teaching techniques. So there is a code reading club I want to mention, because preparing this episode, I found I will post a link to that in the show notes, and I love it. It's like it's like reading code together. It's like a club to read code together and talking about what you see, right? So this leads to some improvements, right? Because first, others can understand better, of course, the code, but some people have specific goals, right? For example, they want to become better at code reviews, right? Or improving their code reading skills. And so it's different people, different countries, different backgrounds, everything, that they go there and they talk about the code. So I think this kind of clubs, maybe if you have I don't know, if you are listening to me right now, you have a club, maybe a CS club in your university, you can encourage to do something like this, because as Ibrahim mentioned, this is very helpful. And I don't know if you know any other tools out there that help students read code. I mean, tools specifically designed for this purpose, or maybe Chrome debugger is enough.
Well, that's interesting to hear about. A code reading club sounds interesting. I don't have any particular tool in mind now, but I would say that there are many code reading activities that instructors can use, as I just mentioned before, in the classroom. But definitely something also that is extracurricular, like a code reading club, where there's more of a social aspect to it, would be nice and interesting.
Awesome. So yeah, just to wrap up, I think we can talk a bit more about AI, because you mentioned that in the beginning of the episode. I recently wrote an article about vibe coding, right? So we are talking today about readability, which is one of the software quality aspects that vibe coding tends to skip. It's so contrary to best practices, right? So I think we can talk about this because, of course, if you are a vibe coder or you only rely on the model to produce the code, to write the code, then I don't know, if you sometimes you basically don't read the code and you copy and paste the code. So this can also, of course, we can talk about problems and we can talk about what this causes if you go to a big code base and you have to do this in your daily basis. But let's see. Well, I'm optimistic about AI, but I'm also considering some problems we can have with vibe coding. So what's your take there?
Yeah, so the way I see it is that when it comes to cars, vehicles, we want some people to be able to drive cars, others to be able to fix cars, and others to be able to build cars, right? And it's not surprising if the number of people who can drive cars is way larger than those who can fix cars, and those who can fix cars are more than those who can build cars, right? And so when it comes to software, it would not be surprising if a large portion of the population is able to vibe code, right? That is, be able to write code using a tool without really writing code or reading code at all, which is fine and nice. It's not only fine; it's really nice. It's empowering and allows people to build things, right?
Yeah.
But when we talk about computer science students, we expect them to go from, like, they should not be at the level of driving cars. They should be at the level of either fixing cars or building cars, right? And so in computer science, we do not expect our students to be at the level of vibe coding only. We want them to go one level below that, or even many levels below that. So the level below it is using some generative AI tool to write code. So that's not vibe coding. That's using generative AI to write code. Or even a level below that, which is being able to write code without any generative AI tool. So in both cases, we would say that code reading skills are very important, right? And
very useful, Ibrahim, because many times students, if they only vibe code, they lose time, because basically you might catch obvious mistakes immediately if you read the code, rather than encountering them, indirectly through failing tests or runtime errors. Maybe you can do this exercise before runtime, right? And maybe you can, if you are, if you are stopped by a mistake and you can't pass to the next exercise, maybe you can do it. You can use AI, of course, to debug or to help you to understand what is happening. But yeah, I think it's a very good insight. And sorry because I interrupt you.
Yeah, sure, no problem. Yeah. The thing is that the goal of our computer science education has to be clear for us, right? If we only want students to be able to produce code, produce software, then vibe coding is one way, but maybe it has a limit. At some point, you need to understand the code that is generated and work on that code. And so, to me, we're still at least in our computer science degrees, we want students to go below the level of vibe coding. So the goal is not only to teach them how to produce software, but also to be able to understand the code that is in that software, and also to modify it or being able to build it from scratch. And so that's a tension usually between us educators and students, because some students no longer see the value of being able to code from scratch, given that there are tools that can produce code, right? That's a tension that we have to address. The other tension is that being able to use generative AI tools effectively is a skill on its own, right? And so it's something that we probably have to consider teaching our students in our classes. So that cycle that I talked about of writing part of the code, getting a completion, like an auto completion from a generative AI tool, and then reading that code and deciding whether it's correct or not, that's something that probably we need to train our students on, not assume that it would just come implicitly when we teach them how to write code from scratch, right? So I use a lot of live coding in my classrooms, and I make sure in some of my live coding sessions to have my let's say AI co-pilot on during the session, and to live code with generative AI so that students can see how I would go through that cycle where I'm writing code, the generative AI produces something, and then I would look at the code and then in a loud voice explicitly discuss what goes into my mind when I'm looking at the code generated by the generative AI, how I'm reading it, and how I'm looking at the corner cases and the different test cases that I need to check, and then how you move on to the other steps.
I think we can dedicate an entire episode to live programming. So maybe, yeah, I will invite you in the future to talk about that. I think it's very cool. And then you mentioned previously the interactive debugging, and debugging for me is one of the, it's very important skill nowadays, because if you don't know how to debug, if you of course, if you haven't read the code, right, it's difficult to debug anything. But basically, debugging is, I think, is going to be a very high demand skill if you are a beginner, a novice programmer, because basically, you have to. Sometimes you have big code bases and everything, so you need to know exactly what to log, and where to put a breakpoint or something.
Yeah, sure. Again, debugging is one of the skills that we at many times assume that students would pick up on their own, and we're not teaching them at many times that skill explicitly. And I think it's something that should be taught explicitly rather than just left for the students to pick up. Yep.
Awesome, Ibrahim. So it was a great talk, and I'm really thankful for your time. Hopefully, we can motivate more students to go out there and read code.
Thank you very much, Daniel, for having me. It was a nice discussion. Thank you very much.
Right. Okay. Goodbye, everyone. See you in the next episode of Computing Education Things.